Good afternoon, everyone. My name is Hermawan. So I will present our project entitled Person Identification System for UAV. So this is a group project by my students Boni, Kokwe, and Dixon. So first of all, we look at what is UAV is. So usually a UAV is consists of three systems: the vehicle itself, right, and then the control system, and also the communications between those two. So from the reasons review, so UAV used for the surveying, surveillance, and also for inspections, and also for the delivery. So a UAV can be either controlled remotely and autonomously. So in these cases, what we focus is UAV used for search and rescue. Okay. So the problem with UAV in search and rescue is it requires two persons. Okay, one is to control the unit, and the second one is to analyze the video. So another problem will be it requires human to be near the search area. Okay. Second is finding a person, missing persons might be difficult for a human. So another thing is additional resources might be needed to train and piloting. So in this project is we would like to develop a system which can enable autonomous UAV in detecting a person within a crowd. So for example, if you want to send medicine, okay, if you want to send maybe food later on, but so that's the some of the things that we are thinking. So this is the hardware that we use. So first we use ground stations, laptops here, and then for the computing power we use Raspberry Pi 4 together with Intel Neural Computer Stick NCS2, okay, and also a web camera as the camera. So this is our drone. This is our drone. So maximum payload will be 2 kg. So currently we have one over 6 kg. So if it's full throttle, the drone can fly up to around 7 or 10 minutes. So this is the flowchart of a system. So first, user can put the upload the data with the phone application. So here we're using Firebase, right? So after that, you need to insert the locations first, and then the UAV will go, okay. And then once it arrives at locations, it will try to do the facial recognitions. Once is notified, one is find it, the user will notify through the phone application. So for path plannings, we are divided into two space, free space and obstacle space. So here we use data from the Google Maps. We conflict with the HHC color space. What we do is here we are using concept of nautical miles. So what we do, we from the workspace coordinate, okay, we change it into different types of coordinate, okay, based on the according to this so-called calculations. After that, what the drone do, it will implement a star algorithm. So this is example of an A star. Okay. So basically, in the map, we divide it into two: free space and obstacle space. The system itself is quite efficient. Okay. For example, this is a building in Nottingham called Trent Building. So here we get around average of 18.5 seconds. So this is the error. So from the actual, okay. So as you can see here, the standard deviations is around 0.01, so which are quite okay. So this is what we do here. This is the what we do. We do some calculations. This is in front of Nottingham. This is our free space. Okay. Now for the facial recognition hardware, so we are using Raspberry Pi, okay, as mentioned, and also Intel NCS2, okay. So this one because we are using deep learning, right? So what the system does is basically from the face, it will transform the face into 128 factors, okay. So, and then what happened after that? What we do, we measure the triplet loss. Basically, for example, you have different types of phases. So it will measure the minimum between the detected phases with the phase that we have in the database. So this is method called triplet loss. So first of all, the image need to be aligned first. Okay. After it need to be aligned, it will be converted into the 128 factors. Then from the 128 factors, we measure the triplet loss. So the one that have minimum loss is considered as the phase of the system. Okay. So the loss itself, we are using Hungarian algorithm here. Okay, for example, since the system will be used for drone, right? So we do different distance. So this one for horizontal. So we find out that the system is able to detect a person up to 3.8 meters. After 4, we find out the system is not able to detect properly. Okay. From vertical distance. Okay, so we, because here is the idea of this one, the drone, right? Okay, so this is, we try to find what is the height that is able to detect a person. So this one from around 1.8 to 3 meters, so the system is able to detect the face properly. Okay, so this one is FPS is frame per second. This one important. Why? Because if FPS low, then if if there is sudden movement, it's hard for the system to identify. So from here we can see that when we have a number of phases in the frame, the frame per second is is getting lower, so which is can be troublesome. Okay, so here we find out that at certain, for example, after 5 phase, then this one is hard for the system to detect the face properly, uh, especially when they are moving. So that's what we find out. Okay. So next, what we can conclude is we are able, the system, we are able to make a system that can accurately recognize person at a height of 3 meters. So the system is able to maintain frame rate at about 5 FPS when recognizing less than 5%. And then for future improvement, maybe we are using more power supply for Raspberry Pi. So currently we are using this one. Yeah, hopefully if we are using a different head, maybe better. So for the system to get faster, maybe rather than using Python, we are using C++. Okay, I think that's all for me. Thank you very much.